全システム準備完了。
All systems are ready.
メインエンジンスタート。
Main engine ignition.
A satellite was developed by the Japan Aerospace Exploration Agency, JAXA, and launched on January 23, 2009 from the Tanegashima Space Center. This satellite was called the Greenhouse Gases Observing Satellite, GOSAT, also known as Ibuki, meaning breath in Japanese. GOSAT shouldered an innovative mission for being the world's first satellite dedicated to measuring greenhouse gases from space. The first step in reviewing effective countermeasures for greenhouse gases is to understand the current status of the Earth. But the density of greenhouse gases is being measured only by about 300 ground stations around the world. So many parts of the globe, including South America, Africa, the North and South Poles, and the ocean are not well covered. In order to obtain data consistently over almost the entire area of the Earth, observations from space by satellite is necessary. Let's take a closer look at how Japanese GOSAT has progressed over the last 8 years in measuring greenhouse gases. In 1997, researchers were participating in field observations of scattered light from the atmosphere at the middle of Mount Fuji and of sunglint on Sagami Bay. They struggled to develop a spectrometer that could measure greenhouse gases from space, conducting numerous demonstration experiments. Since it was a time when measuring subtle changes of greenhouse gases from a faraway place like space was thought to be very challenging, their efforts didn't materialize as soon as they had hoped. The Kyoto Protocol on greenhouse gas emissions reduction targets was adopted in 1997, which served as a tailwind for the researchers because there was a growing interest in reducing greenhouse gas emissions. The GOSAT project began in 2003. Through the steadfast and repeated efforts of the researchers to conduct field experiments, GOSAT was launched in just 6 years. Although GOSAT was launched with great expectations, there were only a few scientists who drew attention to its observation data over the first 2 years.
Before GOSAT launch, the satellite observations of the atmospheric constituents is the accuracy or the precision is about 1% is the best. However, the many researchers from all over the world has worked very hard and collaborate with each other and by improving the retrieval algorithms. And finally, we can achieve much better than 2%. Than many users and many researchers using the GOSAT data.
GOSAT is equipped with a remarkable spectrometer, which can measure the number of greenhouse gas molecules between the Sun, the Earth's surface, and the altitude of the satellite. GOSAT monitors not only the density of greenhouse gases, but also that of oxygen in the atmosphere. The density of greenhouse gases can be measured under various atmospheric conditions, using oxygen as a reference. In order to improve the accuracy of GOSAT, it's essential to accurately understand how solar light reflected from the Earth's surface and scattered from thin cloud and aerosol that passes through both greenhouse gases and oxygen varies with changes in atmospheric conditions. In the desert in Nevada, The NASA team and the GOSAT team have been working together in a joint effort to conduct experiments to enhance the accuracy of GOSAT observations. A former jet fighter equipped with an in-situ spectrometer took flight to coincide with overpasses of the GOSAT. The accuracy of GOSAT observation data is being improved using ground-based and airborne data. Through persistent experiments, only 2 years after its launch, the overall uncertainty for GOSAT measurements fall below 0.5% for seasonal variation in carbon dioxide. What makes GOSAT so unique is that it can distinguish light in more than 10,000 color channels. This feature is what produced unexpected results. This figure is an analysis of plant chlorophyll fluorescence on a global scale, using data acquired by GOSAT. In other words, GOSAT was able to capture signals of plant photosynthesis from space for the first time in the history of humankind. Plant leaves appear green to the eyes of humans, whether plants are undergoing photosynthesis or not, but GOSAT can detect fluorescence signals. GOSAT is also designed to monitor methane density from space. Methane is the second most abundant greenhouse gas after carbon dioxide and comes from various emission sources. It is still not well known as to how much is being released into the atmosphere. Soon after its launch, GOSAT began measuring methane density. Data collected consistently on a global scale over a period of 8 years is foremost in the world. In 2015, Alexander J. Turner, who was a PhD student at Harvard University, wrote a groundbreaking paper using GOSAT data. He found that although North America has one of the most advanced ground monitoring stations in the world, the amount of methane emission had been underestimated. Developing countries have been criticized for not being enforced with strict regulations for greenhouse gas emission. Turner also saw that the amount of emission in these countries have been overestimated to make up for its lack of data.
So I think the combination of both bottom-up estimates and atmospheric observations and top-down estimates can provide some very useful information in understanding how well we're doing for the Paris Agreement. So I think space-based observations can be a very important piece of that.
Based on Turner's paper, NASA announced methane concentration by sources in the United States. Coal, oil gas, livestock, waste, it's possible for all people to collaborate together to reduce methane sources. GOSAT can target emission sources of methane with an agile pointing mechanism and monitor it consistently. Following the request of scientists around the world, the JAXA team makes an observation plan and upload commands. Every day, GOSAT operation is being reviewed so that we can collect accurate data of greenhouse gases from the optimized sampling pattern.
Retrieval accuracy is becoming better and better. But it's not our final goals. Our goal is to estimate the emission sources and also emission locations and the emission amount, and to acquire the data, such kind of flux data, and for future policy makings.
With the launch of GOSAT, global observation of greenhouse gases began to take into effect. Now, this movement has spread not only to the United States, but to Europe and China as well. There's a great awareness now that without satellite observation, we can't observe greenhouse gases globally. In 2018, Japan is preparing to launch GOSAT-2 to observe greenhouse gases more accurately and precisely together with carbon monoxide. JAXA's challenge continues in finding ways to stop global warming.